Okay. Hello, everyone. So, today again, I'm with very good problem, data structure problem on array. And this is very common, popular problem, which is asked in a lot of, again, FANG interviews. And it's very tricky sometimes, and also, give you a basic idea about like how array data structure works. So, what is the problem? Problem is maximum product subarray. So when it comes to maximum sum product array, I think we can quickly go and check what is this problem all about. So maximum product subarray, given an integer array nums, find the subarray that has the largest product and return the product. So we already have, one problem which I have already made a video, which is maximum sum array sum. Okay, but this time we have maximum product subarray. So we have to find subarray, but this time not the sum, but instead products. So when we have done maximum sum subarray, we we had different solutions like iterating to brute force way, but we have done that in a very optimistic, very efficient way of with O of n, because subarray whenever comes in mind, whenever somebody asks you subarray, the very first thing which clicks in mind, oh, subarray, it means we need two loops, right? I, which would be the starting position, and then j will pick the subarray ending position, like so. That's how you calculate everything. So I think similar click is coming again in our mind. um, but can we do this in a better way, so that whenever we are planning to calculating the maximum, uh, like not sub array sum, but instead products, maximum product sub array, can we utilize something from within the things which we have. So we will try to understand this problem, and try to see how it works, because brute force, yes, you can do that. You start with I, j, and then try to maintain, let's say you maintain one particular variable which is max product, and every time you get a subarray, multiply all the elements. Let's say you got a window of I0 j, n. It could be 1 2 3 4 5 till the the maximum size of the element, and then you can multiply all the elements again, like n square, and then inside that what you are doing, you are multiplying it, but it n times the maximum, worst case n times, right? And then comparing this with your max product. So this is one solution which is a brute force. I definitely would not suggest, but yeah, brute force always something which you can explain to the interviewer. Just take only few minutes to explain the brute force, and then directly jump into the real optimized solution. So this is where I would like to start with. So I think you got the particular problem. So let's say I name this maximum product sub array sum. Sorry, not sum. Maximum product sub array. So click, and now I just do uh, main, always input logic output. Okay. Now let me write here the problem statement, which is this, and I go paste it here. That looks good. This is my example one, and then this is my example two. Here we go. Okay, and then later we will talk about time complexity. Complexity and space complexity. All right. So let's start with the input. So what is input? Okay, input is my array. Yeah, it's array always, because we are playing with arrays. Not a surprise. So let me copy this, and here we are good with the input. Now, logic. What is this logic? Integer max product. All right. Yes, that's what we want. And we can have max product method, which can take nums element. And then what is the output? It's simple. S out max product. This is how it works. Okay, simple input logic. I know output I can see. Now I have to write this method. Click here, use IntelliJ power. Now in the AI world, there are many things which are, in terms of AI, which is working. You can utilize those. All right. So, as I said, brute force, Now we will not talk about brute force because we already explained you what is brute force. Uh, can we do something which can solve this particular problem in O of n time complexity rather than O of n square multiplied by k, like O of n square into O of O of n square multiplied k times, right? Or n times. So yeah, yes. Just like we did for maximum product subarray sum, maximum subarray sum, we can definitely do it here as well. The same trick, more or less the same trick, which is maximum product subarray. I will define two variables. One is max product and the other one is min product. All right. So max product, min product will definitely, as the variable name says, will be initializing the maximum and minimum product. And then I will be having my result, which will store the final answer. Okay. And how we will do that? So let me quickly start, and then we will understand the code more. So, as I said, uh, we have to track both maximum and min product, uh, because this array you see here, it contains negative elements also, right? Uh, so, since a negative element or negative number can turn the largest product into a smallest and the smallest into a largest, because if there are two negative numbers, it is necessary for us to track both maximum and minimum. So whenever somebody asks you, hey, can you find the max product subarray, or let's say max product, you always have to have in your mind, hey, yes, maximum product can be, if all the numbers are positive, we are good. Only one variable. But if the numbers are mixed like negative and positive, so just have this thing in your mind. Two negative numbers can also make you positive max product. So that is the reason why we have to have two variables, max products and min products, at each position there. So maximum products keeps track of the maximum product up to the current index, and minimum products keeps track of the minimum product up to the current index. And now the logic, what will it will do? It will be whenever swapping the final answer, because this max and min is not the final answer. We have to have some other variable which should check max product and min product, which is the maximum one, and we swap it with the final answer. So if the current number I is negative, we multiply it with the max product. Will it turn max product negative? If yes, it means, might lower our product. Okay. And then on the other hand, multiplied num by min product, which could be a negative, might yield a larger positive product. So if num size is negative, we swap the max product. And if min product, to ensure that swap the min and max product, um, to ensure that max product always holds the largest possible product, and min product holds always the smallest product at each step. So yeah, that's how this particular solution works. So what I said, I maintain two max product. is nums of 0. Let's start with this. Min products is nums of 0. All right, simple. And why we need to, you know that already, because we cannot, you know, take negative numbers care. We have to take negative numbers very carefully, because very uh, because any negative number, if there are two negative numbers, they can just, you know, make the maximum product. And this is my result, which will work for my containing the final answer. So as I said, I'll just start loop, and loop where nums dot length. And since I already have my zeroth index, you know, work, I'll start with 1. So if nums of I, if it is less than 0, what does it mean? It simply means that we need to swap. Yes. So swap, I think everyone know from the college days that you can just create a temp variable, and you can say max product is in the temp variable, and max product is equals to main product, and then main product is equals to temp. Yeah, that's why that's how we did the swap. And now after swapping, because we are done with the swapping, now we have to update max and min product. Max product is equals to math dot max nums of I, max product multiplied by nums of I, and then min product is equals to math dot min, and then nums of I, and then min product multiplied by nums of I. Yeah, that's pretty much all. And then result. Okay, one moment. Result is equals to math dot max and result comma max product. And I can return here result. Yeah, so that's pretty much all. So let me explain you one more time, which is very simple. Max product y, min product y. Why we are maintaining two variables? We are maintaining two variables because, you know, in an array, if the numbers are negative, these negative numbers can also play the role of maximizing everything. Okay, I'm maximizing the product. So that's why we have to consider both maximum and minimum products. Okay, result is something which we will finalize the final answer. Now we are iterating on this. So if nums I is negative, what does it mean? It means the number I at current index is negative. We swap max product and min product because the negative number will reverse the effect, right? Potentially making the smallest product the new largest and vice versa. So that is why every time we get a negative number, we have to swap. Okay, we have to swap the max product because it can just reverse. Okay, for positive, it's fine. But if it is negative, we cannot ignore it. We have to swap. So over here, you see that temp is max product and now max product is min product. So that I'm just trying to understand like whichever minimum product I had, which was based on, my previous calculation, can we consider this and multiply, my current, I would say, uh, this number, and then check. So that is the reason why it is very important to understand that a negative number will reverse the effect if it is nums I. Okay, it could potentially making the smallest product the new largest. So that is the reason why. And after that, what we are doing, calculating the new max product by taking the maximum nums I of nums I itself, starting a new subarray, or max products into num_sci extending the previous array. So this is extending the previous array, and this one is starting the new subarray. Okay. Similarly, calculate min product by taking the minimum of num_sci, okay, and minimum product into num_sci, and then we update the result. So that's how this particular problem work, right? So uh, I think this particular solution, is pretty clear. Um, so yeah, this is how we actually try to understand. And whenever we are talking the solutions to any interviewer, we should explain uh, these very important things, elements like max product, min product, why we maintaining two variables and all that. Okay, so let's go and uh, try to understand the time complexity and uh, space complexity of this. So as you already see that we are iterating in O of n, so this will be O of n, and then this will be O of 1. All right. Okay, so yeah, that's pretty much all. I think I can run this and check the solution. This is giving me 6. What is the expectation? Yes, it is right. Let me copy this, the other part, and I just copy it here and run this. 0. Is it 0? Yes, 0 is there. It is expected. And now I copy this and just paste the solution, run it. Okay, this is accepted. I submit the solution, and this is accepted. So yeah, thank you very much for watching. Please comment if you have any questions for the solution that I shared. Thank you very much.